Hello my friends of Atari Labs, welcome to this tutorial. This tutorial will be about the determination of flow direction vectors from a MODFLOW model with Python and Flopy. Okay, so what are we going to do today? We are going to do like a missing tool of Model Muse, or like it was missing on Model Muse and it was in another software, but how we can get the flow direction paths. I mean, how we can get like the flow arrows on a MODFLOW model. This is very helpful if you want to simulate, if you want to show where groundwater flow is to where the groundwater flow is flowing. Okay, so how we are going to do this? You are going to find in the description of this model this, like it is a file where you can have the shape file, the scripts, the raster, output, model, and executable. Okay, on the model we are going to work with a single layer model. Actually, this tutorial is for single layer models. Why? Because in multi-layer models it becomes like a bit more tricky to define the water table and the vectors. Okay, so that is why right now we work only on single layer models. Okay, then okay, the model we open on Model Muse, yeah, and then we have actually to run it. Okay, we run it. Okay, it doesn't take long. Okay, if you by interest data delivering results, okay, you want to open the control grid, you can open. This is the control grid of the water of the heads on the active part of the model. Okay, great. Okay, I think it's okay. Yep. So then we close this. I'm not going to make any change. You can do it if you want, but however, these are the files. These are the input files and the output files for the groundwater flow. And then we are going to work with this heads on formatted file. Okay, with this FHD file. Okay, we are going to work with Jupyter Notebook. On the Jupyter Notebook, I strongly recommend that you use this, that you put on your documents. I mean, the folder that you are going to find a description of this model, please put it on your documents, and then it is easier for you to follow this tutorial. Okay, then on documents, okay, then we have the generate groundwater flow and on scripts. This is my and then we are going to have to create a new that is we will call it tutorial. Okay, there is another script that is called flow directions on the single layer, but I am going to use this just for you to understand what is going on. And so first we import the matplotlib, numpy, and flowpy, as well as some Python core libraries. Okay, we run it. Okay, great. Then we are going to find define a background image that is actually this one. Yeah, this is exported from QGIS, and when you export from QGIS, actually comes with this Word file. Okay, why do we use a background image? Because it is better in order to understand where, I mean, the flow direction and the physical things of the geomorphology. Okay, so with this code we open both the Word file and the PNG file. So, and with this is actually georeference. Okay, the image. Okay, then we create a MODFLOW model as an object. Okay, with the flowpy procedure. This is the standard procedure. We create an object that will be called ML. Okay, Then what we are going to do is that on the this file of no okay on the model on the this file Model Muse insert some georeferencing parameters, okay, but as comments, okay. So we have to open this file and read these comments and then georeference our model, okay. So we do this with that, and then when after that we have extracted this parameter, we have to apply to the model, okay. So that's what we are going to do. With this we read with this we read the values, okay, and with this we assign the values, okay. Great, and these are the values, but these are already in this. Okay, please remember that this EPSG code comes from the user, because actually it's not on this file, okay. So you have to understand which is the projection on UTM that in UTM that you are working with, okay. Then you open the FHD file, okay, and with the FHD file you open, and well, it's on the CSH, but for example that you can open many FHD files, and this is the head, but the head like this head is on the this is a sample of the heads, and because I want you to see the heads, this is just a sample, okay. Then we create a figure. The figure is a standard matplotlib figure. Then we apply the background image, and then we create a quiver that is with a function from Flopy. So this, okay, so we create a figure, we open the CBC, that is a binary file for flow. Then we create the flow right phrase that is required for the plot discharge. This is the one that generates the arrows, okay. So I want to show you what happens if I use one arrow for every cell. So then you create, oh sorry, okay, yeah. Then you see that there is one per arrow, but it doesn't show very well, okay. I will create a modification here. Why? Because like I want for the purpose of my tutorial, I want that my scripts will be horizontal. No, that my grid will be horizontal, okay. So how do I do that? Is just I open single model layer, okay. I will go to, you will find this, actually you won't, but I want to explain you what I want that the grid cell size will be 100, because actually, no, 200 is okay, 200, okay, 200, yeah, okay. And but when I exploit the grid, I want 0 degrees of, okay. So, and then with this I save. I don't know what to create, but I delete more results and then I save it. I strongly recommend you to do that, okay. I run the model again. Oh, okay, cool. Come on. Then you have some errors here, don't you see? So you have to go to data, edit data sets, required, layer definition, model top, and then you can have here, you can apply a fitted surface, apply, okay. Then you save it, okay, and then you run it. Okay, let's wait. Let's wait a little bit more. Okay, already You can open the FHD just to see the water heads. Okay, everything works okay. And then here on here I kernel restart and run all. Why? Because this is actually what you will have, is that you will have this. Isn't that beautiful? It is. Okay, but somehow the arrows are not well. I mean, we have a lot of arrows, and the flow directions, they express a flow direction, but it's not that pretty. So we can do this. We can join the arrows. Okay, I don't think that you can join. You filter the arrows only. So then you run it. Okay, and then with this it is better. I mean, like, you can have a better shape of the arrows just by joining them. I mean, instead of having this. Okay, you can join, or you can filter this, and that will be awesome. Okay, great. So this is the tutorial. I hope that this tutorial will be for experienced groundwater modelers. Maybe this is what you were looking for if you were using open source software. Okay, then you can save this image, like like save image as. Okay, or like you can have fig.savefig in output flow direction .png. Okay, I run it again. Okay, and then automatically in output flow direction you have this figure. Okay, and the figure comes with resolution. Then you can, and if you define the figure size here, you can have better resolution. So okay, so I hope that this tutorial will be helpful for you, and then you have found this interactively and very interesting. We are Hatari Labs. Hatari Labs is a blog dedicated to the knowledge sharing in open source software, especially in groundwater modeling. If you like our tutorials, and then if you will be in touch with coming tutorials, please subscribe to this YouTube channel. And if you like what we do, please share our content through your social networks. My name is Saul Montoya. Once again, it was a pleasure to be with you, and hope to see you in coming tutorials. See you, and bye bye.